Assalamu alaikum warahmatullahi wabarakatuh. Today we'll be continuing our talk about the HVAC course in KNX. Today we'll talk about the heat distribution system, which is talking about how heat is being generated from one area and distributed to the rooms. Let's say you have a villa, and then you have maybe the heat distribution system in the basement, and then you are transferring the heat from the basement to the other rooms in the villa itself. And how what are the different systems doing this kind of distribution? Okay, we'll talk about this today, inshallah. Fine. First system we have is something called two-pipe system. As you can see, there is here the boiler, which is distributing the water. Sorry for that. You have here the boiler. And then you have two water flows, mostly the flow from the boiler to the heaters itself. These are the heaters in your room. Can be a radiator or something like that, but this is in your room. And then those heaters are getting the hot water, and the flow back is the cold water, because water is getting inside in very hot. Then they are leaving the heaters after losing some power, which is the thermal energy that will be convected to make us comfortable, getting back as a cold water. So in heating technology, the heat transfer medium of water is transported via pipes and channel ducts. In the two-pipe system common today, the radiators are connected to the flow and return flow. This is a very simple two-pipe system for the heating distribution system. A lot of variation from the two-pipe system. You have the vertical variation, where the heater or the boiler is located in below, and then water is distributed from below to above. So you can see here that hot water is coming first above, one by one, okay, and then cold water are getting down. So this is what we call two-pipe system with distribution from below. This is the vertical distribution system. And then you have another one. The other one is the different one, where hot water is going above, and then distribution from above, not from below. So I'm getting down. Okay. This way, distribution from above, the flow first moves up to the attic and then comes down from the attic into the down pipes, while the return flow is collected down into the basement. This method is no longer used today, as it requires more piping. As you can see, it needs a lot of piping, so it's a bit expensive, so it's not used today. The other one is the horizontal one, where then the heater or the boiler on the same level as the heaters themselves. So you can see here the boiler is here, and then distributed to this one first, then this to the second one, then and vice versa. And this is the flow, and this is the return flow. So horizontal pipe systems are easy to install, of course, by using a distributor on each floor. Heat meter can measure the thermal energy. You can put the heat meter here. Okay. Then you can also calculate the energy flow. Then another variation of this one, that was the parallel arrangement, or a ring-shaped one, like they're connected in serial. And then another variation is the one where they have a star-shaped one connected in parallel. Okay, you can see that from here, you have a complete back on and back system, and here and as well here. So this is a star-shaped one. Okay. This is, of course, from here it looks more efficient, but of course it's more expensive than you have, because you have more pipes. Another one is called a Tichelmann system, and then you will get a lot of variation from the Tichelmann system coming now. The Tichelmann system was mostly used. Okay, it's not used anymore now. There is a more advanced one. We'll talk about it later. But it was most used because in the other systems, as you can see, when the hot water is coming to the first radiator, it will be more efficient than the second radiator, because the first one will take more heat, then the other one will be less heated. And then the pressure is uneven. It's not the same among the radiators. The Tichelmann system is trying to solve this. And a lot of variation for the Tichelmann system. Let's take a look. Here is the one pipe system, okay, single pipe heating. And here, because of the many disadvantages of single pipe system, it's not used anymore. But it depends on that you have here the boiler, and then you have one pipe going to the heater, okay? And the same pipe getting the flow water. So it's one pipe. And the issue here that the cold water is going in the same direction. So the hot water is coming here, and then the cold water is coming here. So the cold water is also going the same direction as the hot water, which is not very efficient. The flow temperature must be set higher. So here you have to make it very high to compensate the return of the flow water, the cold water. And this one is not being used anymore, by the way. The other one is using thermostatic valve, and this is what is used mostly in these times. Have this specific valve. The valve itself had a thermostat in it. So the valve will adjust its opening and its closing depending on the temperature itself. So when the temperature is high, then the valve, the water here will expand, then the valve will close. Meaning that less hot water will come, so the system will allow to cool down a little bit, and vice versa. So valve fitted to the floor automatically limit heating water flow when the room temperature rises above the set value. This is the thermostatic valve. Here you also have a curve talking about the efficiency between the pump curve and the operating point. Don't really need to understand that, but then you have a flow volume, and you have loss of pressure, and the optimum point you have is the equilibrium between the flow volume. So as the volume increases, okay, pressure decreases. So a manpower curve is graphic depiction. Heating system by network have a so-called network power curve, which is parabola shaped. Network power curves are vary based on the pipe length, okay, and the rotators. Then another one called hydraulic balance. In hydraulic balance system, okay, and the balance is based on the valve itself. The hydraulic balance is based on lack of hydraulic. In case you have lack of hydraulic balance, you can see that the pressure here is uneven. You see here, this one have excessive power supply, and this is less, and this is less. In a hydraulic balance system, and the hydraulic balance is coming mostly from the valve itself, okay, then you can see that the pressure here is even. So if heating systems are not hydraulically balanced, just like this case, no heat will reach the radiators at the end of the heating circuit. This one will be having very less heat. Therefore, a hydraulic balance differential pressure, this one that we need compensation, must be performed on heating balancing. Like balance is the process of lowering the flow rate to the front or to the lower radiator in the building to make sure that the heat balance among the radiators are the same. Heating surface, we talk here about the heating surface. You can see here this heating surface that you have, and you can compensate the heating in the surface itself by the temperature rising in it. And here is talking also about difference between two things, the radiation and the convection. The convection is when you are heating one area or one system, like the radiators, and this heat is converted from the radiator to the air. And in the radiation, you are heating the air directly, like the normal fire heater, the number one, that like the fire. So you are putting the high temperature directly to the air, not convected, okay? And then it leads to something else, that sometimes the radiation itself is not sufficient for us. Sometimes you are, the one heater is not enough for you. You want to make heating in the wall itself or in the floor itself. So now we'll be talking not about the normal radiation in heater, to talk about how to heat the surface wall itself. So heater installation below window for invent the air temperature essentially balance. This is the one that we normally use, okay? That we put the heater in the coldest area, okay? And then in the next slide, we'll talk about that assembly of heater and temperature sensor. So you have in your room a heater and a temperature sensor. So what is the relation between the heater and temperature sensor? So to achieve an even heat distribution in the room, install heaters in the coldest spot, usually under the window. This is the heater itself, like here. Okay, this is the window, this is the heater. The heater should be at least as broad as the window, so its width should be as big or as wide as the window itself. Then the thermostat itself, where you have the temperature sensor, the temperature sensor should be normal to the length or the height of the normal person, okay, and installed away from the door. Put it away from the door, at least this distance, and at least this height. This is the relation between the heat sensor or temperature sensor and the radiator itself. Then different type of radiators, we'll talk about them here. So the cast iron radiator, this one is so expensive now. And normally you calculate its efficiency based on how many sections you have. So it's a section, which is N, and then the width and the height of the section itself. And this is how you get these calculations. Okay. This one used to be used a lot. It has a very long lifetime, but it's too expensive now, so it's not being used anymore. Another variation, okay, is the steel one. The steel radiators weight half as much. The lifetime is not that high, but then you have a lot of variation from them, like this one, like this one, like this one. Another concept as well is the steel or the convection like that you have a sheet in here, and then you get getting this temperature and the water flow coming by the sheet, okay? Okay, which we call it sometimes convector heaters. This is a steel cover with contains very little water. Or you have an air heater, which is used mostly in bigger areas because it's a bit of loud. Then you have a heater and you have a fan pumping air to the heater, so you are getting the hot air in your house. So air heaters are primarily used in large workshops, industrial installations, and storerooms. They consist of a heating coil heated using hot water or steam, okay, and multi-speed fan, which is pushing hot air to your area. Another way also to heat surface, sometimes you heat the wall itself, okay, and sometimes you heat the floor itself. So the surface heating is radiant heating. For heating itself, advantage for the floor heating, so no visible heaters. Okay, so the floor itself is heated. Okay, very hygienic, low convection, little dust disposal, warm floors and balanced room air temperature, so you make it more comfortable for you. Condensing boilers and water pumps are particularly about because of the heat water temperature. The disadvantage is higher temperature price, it's too expensive, difficult and expensive to repair in the event of leaks. Okay, sluggish heating up thick floor screeds. So the floor should be a little bit high to allow that you have the pipes installed under the floor itself. And of course, increased heat loss downwards. Then you move to the symbols of heating systems. You don't need to memorize this, but then you have in the PDF a lot of symbols that you might see in an HVAC, let's say, manual, or in a heating system coming to you. Then you'll be able to understand this. A lot of them, you can go through them. These are the valves, an example. These are the type of pipes. Then you have the shut-off and control valves, different type of valves as well. These are the safety valves, and each one will have different way. You can go through them in the PDF itself. And this now we're done with this chapter. Next chapter will be heat generators, inshallah. If you have any question, let me know. From this chapter, by the way, you just need to understand the different type between the heat generators, the heating systems, that you have two pipe system and pipe system. You have the floor heating or the wall heating, and also that you have how the water is going in a vertical way or horizontal way, the star-shaped or the parallel-shaped ones, and then where you should locate the heaters or the radiators, which we said nearest the window, and where you should locate the temperature sensor, which is at specific height with specific dimension from the door itself. Okay. If you have any question, let me know. I'll see you inshallah Rabbil Alameen in the next chapter. See you. Assalamu alaikum.